About 66 million years ago, a large asteroid crashed into our planet and eradicated 75% of all plant and animal species, including all non-avian dinosaurs. This mass extinction event, known as the Cretaceous Paleogene, or KPG extinction, forever changed the trajectory of life. Let's rewind to that fateful day when the dinosaurs took their last steps on Earth. The KPG extinction event marked the end of the Cretaceous period, a warm and humid time on our planet as greenhouse gases accrued in the atmosphere. During the Cretaceous, the concentration of CO2 may have peaked at around 2,000 parts per million, roughly 5 times greater than our atmosphere today. With substantial greenhouse gases present, global temperatures averaged 5 to 10 degrees Celsius higher, and the weather remained mostly warm year-round, with only mild seasonal variations. This climate supported lush tropical environments around the equator, with temperate conditions extending into much higher latitudes than seen today. At the time, much of Europe, Africa, and the Americas were covered by open canopy forests and woodlands. These rich biomes were populated by a wide variety of prehistoric plants, including ferns, conifers, and flowering plants. The forests were also home to ancient relatives of modern animals like arachnids and early marsupials. Beyond the forest's edge, many low-lying areas were covered by shallow inland seas. The polar ice caps did not exist back then, and the oceans were warmer, so sea levels were significantly higher. Rivers and lakes often spilled over their banks, creating vast wetlands and swamps. These damp, humid ecosystems were home to all sorts of terrestrial and semi-aquatic organisms. Amphibians flourished along the water's edge, coexisting with arthropods and bony fish. These smaller creatures also attracted airborne predators like primitive birds and flying reptiles called pterosaurs. However, the most dominant animals were sometimes gigantic reptiles known as dinosaurs. By the late Cretaceous, these dinosaurs had evolved into some of the largest terrestrial creatures to ever walk on Earth. Massive browsers like Argentinosaurus used their towering necks to feed on leaves on the tallest trees. Bulky ceratopsians and hadrosaurs roamed across open plains in multi-generational herds. Alongside these massive herbivores lived powerful and ferocious carnivores like Tyrannosaurus rex and feathered hunters called dromaeosaurids or raptors. The day the asteroid struck the Earth was a day like any other. Across forests and floodplains, animals were engaged in their daily activities. A herd of ceratopsians grazed on low-lying vegetation. A large male T-Rex searched for its morning meal, while pterosaurs soared through the skies, perhaps landing on a nearby tree or cliffside. Small mammals crawled into burrows, where they ate and cared for their young. Fish and marine reptiles swam in the ocean shallows, all unaware of the devastation to come. Some of these animals might have looked up to see a rapidly brightening point of light speeding across the sky. What they might have seen was a C-type asteroid, roughly 10 kilometers in diameter. Just seconds before impact, the asteroid entered Earth's upper atmosphere at an angle of roughly 60 degrees from horizontal and raced towards the surface at about 20 kilometers per second, or 45,000 miles per hour. As the asteroid became visible from the surface, the dinosaurs, mammals, and other creatures had no time to escape, their fate all but sealed. As the asteroid hurtled toward the surface, it compressed and heated the air around it. This raised temperatures on the asteroid to several thousand degrees Celsius. The exterior began glowing brightly, and a blazing trail of plasma formed in its wake, a spectacular and terrifying sight visible for hundreds of kilometers around. Next, the asteroid reached lower altitudes, where dense air and greater atmospheric pressures created more resistance. As the asteroid punched through the lower atmosphere, its forceful descent generated a powerful shockwave that traveled outward faster than the speed of sound. With that shockwave came a deafening roar, a chilling sound foreshadowing the near annihilation of life on our planet. Finally, all that explosive energy vaporized most of the body of the asteroid as it deformed the Earth's crust. The ground rapidly melted and collapsed, forming a crater almost 200 kilometers wide and 20 kilometers deep. Within an instant of impact, the blast site was swallowed by a towering fireball exceeding thousands of degrees Celsius, An intense pulse of heat radiated from its center, incinerating everything it touched. All living organisms near the impact zone were charred or vaporized, from the smallest mammals to the largest dinosaurs. At greater distances, the blast wave and thermal radiation ignited massive wildfires that rapidly spread, thanks to an abundance of flammable plant material and extreme winds. The immediate impact also launched billions or trillions of metric tons of debris into the atmosphere. Some materials flew high enough to reach the upper atmosphere or even escape into space. The rest poured down on the surface like dark, deathly rain. This debris ignited another wave of fires across the globe, which consumed entire ecosystems. Across forests and swamps, organic matter combusted on a massive scale, releasing staggering amounts of smoke, soot, and carbon dioxide into the atmosphere. All that gas and debris collected into a thick cloud that darkened the skies, ushering in an impact winter. Over minutes, hours, and days, this blanket of smoke and debris spread across the Earth, preventing sunlight from warming the ground and thus cooling global temperatures. As this dark cloud expanded overhead, a global tsunami radiated from the impact site. When the asteroid struck the Earth, it not only displaced rock and debris, but also enormous amounts of water. Near the impact site, the initial wave may have reached 1,500 meters high, or almost a mile. Even 10 minutes after impact, waves climbed hundreds of meters tall and traveled hundreds of kilometers per hour. Some of these tsunamis were large and fast enough to cross entire ocean basins, inundating faraway coastlines with surges of unrelenting waves. These tsunamis were especially devastating for low-lying coastal environments like swamps and wetlands. The waves landed with enough force to uproot trees, erode soil, and reshape coastlines. Entire habitats were submerged underwater, drowning or sweeping away countless plants and animals. These tsunamis also left behind saltwater and sediment, which would disrupt the balance of coastal and freshwater ecosystems for decades to come. In the minutes after impact, the devastation continued as seismic waves, compared to the strongest earthquakes ever known, rattled our planet. The initial quake may have opened cracks in the ground and shook the Earth with enough force to topple forests. Even after the first earthquake passed, a series of aftershocks continued to shake the ground for minutes or hours after impact. These aftershocks activated fault lines and triggered landslides, both terrestrial and submarine. Along seamounts and underwater canyons, falling rocks and debris devastated some of the richest underwater habitats, damaging populations of fish, invertebrates, and marine reptiles. If a giant asteroid wasn't catastrophic enough, violent volcanic eruptions were occurring in the Deccan Traps halfway around the world. These volcanoes had been erupting for roughly 300,000 years before the asteroid strike and would continue erupting for at least 500,000 more. On top of regional devastation, these eruptions pumped trillions of tons of carbon dioxide and sulfur dioxide into the atmosphere, contributing to the dark layer of clouds that was swallowing our planet whole. The eruptions at the Deccan Traps may have even been catastrophic enough to trigger a mass extinction event all on their own, but it's important to recognize that the asteroid was the foremost cause. Together, they delivered a 1-2 punch that life on Earth almost did not survive. Over weeks or months, our planet sunk into cold darkness as life was pushed to the brink. The lack of sunlight prevented producers, like plants, from performing photosynthesis. These organisms died in record-breaking numbers, causing global food chains to collapse from the bottom up. As plant populations declined, herbivores struggled to find food, and their populations plummeted. In turn, carnivores and scavengers lost their primary food sources and struggled to survive. The same cascading devastation affected marine food webs as phytoplankton greatly declined, impacting almost all organisms, from the smallest fish to the largest marine reptiles. This day is often known as the last day of the dinosaurs, though some species survived beyond the initial days or weeks after impact. Certain non-avian dinosaurs may have persisted for thousands of years longer, but the ecological fallout was too significant for them to bear long-term. The large bodies and demanding diets of many dinosaurs made them ill-suited to the changing conditions on our planet. As the late Cretaceous gave way to the early Paleogene, non-avian dinosaur populations declined to extinction, while smaller, resilient opportunists found ways to thrive in this catastrophe-laden world. Early marsupials, for example, hunted in darkness and retreated to the safety of underground burrows, granting them shelter from the dark clouds billowing overhead. Eventually, a new equilibrium took shape on Earth. Debris slowly settled out of the atmosphere. allowing sunlight to once again shine down on the surface. Ecosystems recovered as populations of plants and phytoplankton steadily increased, allowing those resilient survivors, like small mammals, to evolve and diversify. So began a new age of life that paved the way for the many species that dominate our planet today, including humankind. The story of the dinosaurs' extinction is not just a tale of death and destruction, but a testament to the enduring nature of life through even the darkest moments.